Okay, here we go. Starting a little stopwatch there. This should be lecture two of unit one on correlation and experimentation. You should be on vocab one, and this is the second part of it. We're going to start with correlation, and we're going to take it on through to, I think the placebo effect is where this one will end. And again, as always, if you get to this and you don't want to watch all 30, 40 minutes, however long this one ends up being, if you've got a question, you've got a blank in your outline, whatever, fast forward through it, get to the point where you want to go. I will go in sequential order. So always feel free to fast forward through it to get your understanding of something you might have missed in class. All right, so the previous lecture, we talked about different types of studies and how we observe and do all these other things. Well, in these observations, what we want to see is there a relationship between this and that? When we talked about having a hypothesis, for example, I think this is a predictor of that. Well, how much could this be a predictor of that? And that is a correlation. And again, for those of you guys who have taken statistics or whatever at this school, this is going to be sort of, yeah, but let's keep in mind we're using it for psychology. And with psychology, we've got all these factors that are going to have a big effect on it. So a correlation, again, is a statistical measure of the extent to which two factors vary together and thus how well one will predict the other. We're not saying it causes it, but this will predict that. When you see this, expect that. That is correlation. Now, there's a couple of different types of correlation here. Let me take my face out of the side here and move it over so we can see this. One sort of a factor in correlation is what's called a positive correlation. And a positive correlation means as this goes up, that will go up. Or as this goes down, that will go down. Positive is they're just going in the same direction. For example, the more I eat, weight goes up. The less I eat, weight goes down. That's a positive correlation. An addition in one area is going to be an addition in another, or a subtraction in one area will be a subtraction in the other. They're both going to go the same direction. Either both the x and the y will go up, or both the x and the y will go down. That is a positive correlation. Now, on the other side is a negative correlation. And a negative correlation, again, all we're doing is talking about directions, all right? As this goes up, that will go down, or as that goes down, this will go up. The confusing part on this is usually we think, and we got to get out of this with psychology, because usually we think of negative as a bad thing and positive as a good thing. It's not necessarily true, because if we have this positive correlation here, the more I eat, I'll gain weight. Well, if I don't want to gain weight, that's not a positive thing, but that is a positive correlation. And over here, you know, the less I eat, the less weight I'll gain. That's also a positive correlation. That could be a positive thing. The more I work out, my weight will go down. I work out more, weight goes down. That's a negative correlation, but that could be a good thing. That could be a good thing. Or if you're someone who's trying to gain weight, you want the opposite of that. So again, this is just saying that one predicts the other, not that it necessarily causes it. Knowing how much an IQ test correlates with success tells us how much it can predict success, but it doesn't mean that it's causing it. So, and we'll get to that in a little bit later. So what we're looking for is what is called a correlation coefficient. And it's just basically a formula that decides that as this goes up 5, that goes up 5, 5 over 5 is 1. That's a perfect positive correlation. So perfect positive is if this goes up the graph, that goes across, and they do it at the same rate. That's a positive correlation. The perfect negative, as this goes down, that goes up, or as this goes up, that goes down. That's a perfect negative correlation. All right, so they go the opposite direction just as much. So a perfect positive is going to be in that 1 to 6 range. This is where you've got a lot of a relationship. Over here in negative, this is where you have a lot of a relationship. But in the middle, where you've got a correlation of a 0 or a negative 0.1, negative 0.2, or positive 0.2, 0.3, there's not really a predictable correlation that is there. Here is a little sort of a graphic that if you need a little bit more of an understanding, you can go back and read it. But again, a more solid connection here, a more solid connection there, a less correlation when it's closer to a whole 0. Now, what we're going to do with this information is once we gather data, we take a survey, do whatever, what we do is we like to take the information, we like to put it on the scatter plot, which is just basically a graphic of dots that we put it. You've got your dependent variable and your independent variable. Remember, the independent variable is something I changed, and the dependent variable over here is the result of this change. This goes up by 5, that goes up by 5. This goes up by 10, that goes up by 10. This is a perfect positive correlation if everything went together. So a perfect straight line is going to be a perfect positive correlation. Let me give you an example of a scatter group. This is a question that students always ask me is what does my grade, what sort of grade do I need to get in AP Psychology in order to do well on the test? Well, here's the trick. Your grade in AP Psychology doesn't cause you to do well. You know, they're kind of irrelevant things. You take this, I think this is from a couple of years ago, Hurricane Harvey, if I'm not mistaken. No, this is a tax day flight, if I'm not mistaken, because I know that you had this one student who did really, really well in my class, solid student, took it in the fall, fall is blue, red is spring. These two yellows are kids who took on-level psychology and still, you know, passed the AP exam. But this girl had things going on, so she's an outlier, someone who did really well in the class but got a 1 on the test. Where even over here, you had some kids who did, you know, maybe not extraordinary in the class, but still got a 4 or a 3 on the test. So you had some outliers, but pretty much the grade that you got in class, the higher the grade was a predictor of more success, the lower the grade was usually a predictor of less success on the exam. So that is a positive correlation. It's not perfect because there are your outliers there and your outliers there, but it shows a general sort of trend. If you take a look at this, it's 2018. This is where you sort of break it down. The kids who got a high A, high B, low B, C, D, F, and then the number who took the test, and then how they did on the test. And you'll generally see that as the better you did on the test, the higher your average AP score and the higher the passing rate in the particular class. And so you sort of have this general positive correlation when you plot it out that kind of goes along with that. Now, things that you have to consider, you take a look down here at the kids who failed. I had 8 kids who failed, but only 1 who took the test. 17 kids who got a D, but only 7 took the test. So you don't have as much participation down here as you have up here. So we don't have as good of a sample down here as we have up here. So these are all things that we have to take into consideration. Here's another example. You take a look at the test from 2019. There was a pretty strong positive correlation that went straight up here, where you sort of, and you see this core in the middle and going on up. The better you did in class was a good predictor of how you were going to do on the AP exam overall. Again, the kids in the blue were fall, the kids in the red were spring, etc. Then you take a look at 2020, which was the COVID test, which is where, again, 86% of schools teach this over a year. So they said, hey, listen, we're going to cut it off at this point. Don't worry about the last 3 units. Well, the last 3 units for them isn't the last 3 units for us. And so I still had a third of the material to go over. So kids did not do as, there was a little bit of a drop in the passing rate, but not only that, but with COVID, there was an increase in the grade average. There was this grade inflation that occurred, that if you got an 89.5 in the class, that was factored in as a 99. So someone who probably would have normally gotten a B in the class is suddenly getting A's in the class, or someone who may have gotten a C is suddenly getting a B, or even a D is getting a B. And so you've got these kids over, you've got a lot more A's and B's who got a 1 on the test, or even a 2 on the test. And then you had, again, a lot of grades up here. Notice all these A's and B's, whereas here it was very crowded, here it's not. So again, those are variables where when you compare one to another, is it always an apples to apples study? Sorry, my chair's squeaking a lot. But is it always an apples to apples study? Something we have to take into consideration. Another example of correlation. So let's say I have a theory, who barks more, little dog or big dog? Well, little dog tends to bark more because the little dog got to prove itself. Big dog doesn't need to bark, he's a big So the little dog is more likely to bark. The little dog feels a little bit more defensive about himself and everything else. So if somebody takes that idea and changes it to humans, who's more likely to get scrappy and get in a fight, little guy or big guy? What's their temperament? So someone basically had this theory of the shorter you are, the less likely you are able to control your temper. Yet you're going to be more reactive. And the taller you are, the less likely you're going to be reactive because you're probably challenged less and everything else. So what they did is they took 20 different subjects here. How tall are you? And then what was your temperament score? And the higher your temperament score means the easier it is for you to control your temper, and vice versa. So if we take a look here, again, this is our graphic. And then over here is where you put a plot. And you do see a general trend that the taller a person is, and by the time you're up to 70 inches, you're at, what is it? 72 would be 6 foot. 72 would be 6 foot? Yeah, 72 would be 6 foot tall. So this is 6 foot tall, and then this is under that, and then this is over it. And what they generally saw was the taller that you were, the more likely you were able to sort of control your temper, and the shorter was less likely. Now again, there are outliers to this particular thing. You'll notice here you've got a person who is 80 inches tall, so you're talking about 6'8", has a lower temperament score than somebody over here who is, 7, right about there. So there are those exceptions to the rule, but you do sort of see a general trend going up. And now again, we're not saying that height is a cause of it, but we can say when we put it out here that this will predict this. If I have this, it is a predictor of that. And that's a correlation. Again, a perfect positive correlation, if you want to draw this on your little graphic, is as this goes up by 5, that goes up by 5. This goes up by 10, that goes up by 10. It's a perfect positive. A perfect negative means that as this number goes back, this number goes down as well. Here it's 10 and 10, there it's 5 and 5, and that's a perfect negative. Now again, positive and negative aren't necessarily good or not necessarily bad. For example, here's a couple of examples. Number of days I attended class, number correct on the exam. How often you attend class is a predictor on how well you'll do in the exam. Now again, it's not, there's outliers there, but this shows a general trend going up. Versus here, the number wrong on the exam versus the number of days I attended in class, the wrong, I'm going to get more wrong in the fewer days, and that's a negative correlation. As one goes up, the other goes down. Here is the number correct on the final exam, the day of the month you were born. Well, the day of the month has nothing to do with the number that you got correct. So this is kind of a zero correlation because one really isn't a predictor or has anything to do with the other. Positive correlation, again, does not necessarily mean good news, or negative means bad news. The more you eat, the more weight you gain. It's a positive correlation. Not everybody, some people want to gain weight. You're younger, you pull involved, whatever. But most of us want to sort of control that. So it's not necessarily a good thing. The more that you run, the less time it takes to run a mile. Well, I'm training more. My mile time goes down. That's a negative correlation, but it's a positive thing. So again, when you take a look at these graphics here, you go back over the PowerPoint and they'll show you a bunch of positive correlations and negative correlations and no correlations and sort of how it all works in if you want to review it. More right there, just as review. Better examples. Now, there's something that's called the third variable problem. And the third variable problem is an observed correlation between two variables, maybe the result of a common correlation of a third variable, rather than these two things that are being studied. So there could be something on the outside. For example, watching violence on television correlates with and can predict aggression, but doesn't mean that violent programming causes someone to be aggressive, because that's a big leap. We survey a bunch of people who tend to be violent, and they tend to watch violent programming. So can we say that the violent programming causes them to be violent? Maybe, but maybe their temperament is already violent. So being a violent person, I'm going to prefer violent television. If I'm a violent, aggressive person, I'm not going to be sitting back watching My Little Pony. So it could be kind of an opposite thing that causes that. It could be my temperament. It could be backwards. You know, most people with depression have low self-esteem. So can we say that low self-esteem causes depression? No, not necessarily, because my depression may cause my low self-esteem, or maybe both are caused by something else. There's something else going on with me. I got something that triggered it, and it's led to both low self-esteem as well as depression. So that third variable, because again, we're complex people. We're not just hydrogen and oxygen putting together. We're complex. We've got backgrounds. We've got histories. We've got journeys. So it's kind of our journeys. I sound like I'm a bachelor, but we have all of these other factors. So again, it's really sort of tough. It's really sort of tough to just say this causes that, which is why experiments are very important, which is the next lecture. So again, correlation versus causation. Correlation can predict an outcome, but it does not necessarily prove causation. For example, as ice cream sales increase, the rate of drowning deaths increases sharply. That's true. It's a fact. It's indisputable. There's numbers that prove that. But does that mean that ice cream causes drowning? Of course not. Of course it doesn't. But when are people more likely to swim? In the summer. When are people more likely to eat ice cream? In the summer. There's my third variable. It's the summertime. So the summer's causing the ice cream sales, and the summer's causing more people to swim, and the more people that are going to swim, the more people that are going to get in an accident. Well, there you go. All right, a longer a man is married, the more likely he is to be bald. So can I say marriage causes you to go bald? Of course not. The longer you're married means increased age, and with increased age, there's going to be that inherent way to go bald. Now, can marriage cause stress and stress cause baldness? Yeah, maybe, but I can't just make this blanket sort of predictor there. People who eat diet food weigh more than those who do not. So am I going to say that diet food causes you to weigh more? Of course not. People who are more likely to eat diet food are people who are overweight and want to lose some weight. So it's not that this causes that. This is a factor of that. People who wear hats are more likely to suffer from skin cancer. Well, people who wear hats are more likely to have fairer skin. It's the fairer skin that is probably going to be more likely to cause the skin cancer. The more antibodies a woman takes, the higher her risk for cancer. Well, the higher your risk for cancer, the higher your risk for a lot of diseases. And if you're at a higher risk for a lot of diseases, you're more likely to take antibodies. So again, and this is where we get to those weird sort of the vaccinated, the anti-vaxxers sort of belief of, oh, this happened, then, you know, my child got the vaccine and then they were diagnosed as being autistic. Well, it's because your child got the vaccine at 4 or 5, when most all children get the vaccines, and you don't diagnose anybody with autism until they're about 5, 6, or 7. So it's just the timing of the tests. You know, whether you got the vaccine or didn't get the vaccine, that's not going to affect the autism. It's not a cause of the autism. Although you'll have people get on the internet and make crazy claims like that. As alcohol prices go up, the number of STDs reported goes down. There might actually be something. All right, so when we talk about correlation and causation, another graphic right there that you can sort of look at, and if you want to get other examples, they're all there for you. Feel free to pause and take a look. And again, more examples of correlation and causation and how that all works. Very interesting here on how the brain activates in gaming. And does it, you know, the video game does cause the adrenaline rush, and it causes the dopamine and the reward and the aggression. And there are studies that are starting to show that, yeah, it could be a little bit of a cause of aggression and an addiction to rewards and fast rewards. This thing is an addiction. It's a dopamine rush. I got a text message. Ooh, it's information, you know. So there is a little something here that we'll talk about down the road. But at the same time, video games can also be very cathartic. Rather than punch my little brother, I'll go destroy some pixels. Could be a good thing too. So it's when we look at one study and then we go, this is a blanket thing of how the rest of the world is, it's kind of a dangerous thing to do, because that's where we come up with something called an illusionary correlation. And an illusionary correlation is when we're trying to explain something in simplistic ways, but we're not really taking all these things into factor. We perceive a relationship when there is no relationship. Because we only recall and the biases or the heuristics that are available to us, and it makes a simple explanation for what's usually a very difficult thing. which is why people, are making arguments against masks and whatever else that is not scientific or logic. They're using these little sort of minuscule anecdotes as their science. I read on the internet, and everybody's sharing the same one story, and you think it's happening everywhere. People who conceive after adopting catch our attention because it's a freak story. We take a little. Here's the situation. Couple, and I'm sure most of us have heard of this story somewhere. A couple tries to have kids. They're unsuccessful. They try. They try to go to a fertility doctor, and they try everything. Put the eggs in there, put the sperm in there, put it in the blender, put it back in the oven, whatever. They've tried everything, and it didn't work. And they spend thousands and thousands of dollars. It doesn't work. So they decide to give up and adopt. And after they adopt, 6 months later, boom, woman's pregnant. And people go, oh my God, yeah, I heard that story. Yeah, that happens all the time. It almost never happens. But since that one story gets shared everywhere, especially with the internet, then we all think, oh, that's the truth, when that's the exception. The truth doesn't get our attention. We ignore everybody who conceived without any problem. Those go away. We ignore the people who go and get artificial insemination, and it does work. We ignore the people who just adopt and never get pregnant. We only hang on to these freak stories because the freak stories are interesting. Most superstitions that we have are based on illusionary correlations. And if taken to the extreme, it can lead to OCD. That one time I did this one thing, this one good positive thing came up. So I need to do that one thing again and again and again. Or this one time I did this one bad thing, and then this bad thing, I could never do that bad thing again. And that's where you got OCD, the person who turns off the light and then it went back and it was on, so they turned it off twice, and now it was really off. And that's OCD, which we'll talk about, temporal disorders. We want the world to make sense. And it's a complicated world, but the world doesn't make sense. And we also have this delusion idea that the world is fair. The world is not fair. Time is infinite. It never has to even out. The world is not fair. Look at the size of my head. The world is not fair. Some people were born winners of the genetic lottery and were born beautiful and are going to have advantages in life. And some of us had to develop a sense of humor in order to get attention, whatever the case may be. So we think that the world is fair and it's going to even out, and that's not true. But we sit there and we play it. Again, you take a look at these two hands. Right here, if you're playing poker and you shouldn't play poker, gambling's wrong. If you're playing poker, this is a perfect hand. This is a royal flush. This cannot be beat. It's 10 to the king. They're all the same suit. This hand is just crap. You've got 4 different suits. You've got 8 high. There's no real chance. And maybe if you put this in, I get a 7, I get a straight. But it's just a really bad hand, because even if you got a high card, it's a low high card. It's just not a good hand. You fold that. So we got crappy hand and we got good hand. So what are my odds of being given this great hand versus this crappy hand? And they're even. They're both 1 in about 2.6 million. It's even. But the problem is since this is an exceptional hand over here, and this goes along with a bunch of other crappy hands, we assume that the odds of getting this are greater. But it's not. It's exactly the same. Now, if we say crappy hands versus great hands, the odds are different. Playing the lotto. People will play the lotto. Your chances of winning the Powerball is 1 in 272 million. 1 in 272 million. Yet people will still go play them. I told the story, I don't know if it was last lecture or the next lecture, of the guy who walked in without wearing his mask because he's like, well, what are the odds I'm going to get COVID? Yet he played the lottery. We think we're special, so the good things are going to happen to us and the bad things aren't. Or you're on the other side of the equation. You never believe the good things are going to happen, only the bad things, which is reasons for anxiety, depression, and whatnot. Coin has a 50-50 chance. If a coin lands on heads 5 times, the odds of it landing heads next time is 50-50. You play roulette. You shouldn't play roulette because gambling's wrong and immoral. But you could bet on the red or the black or the odds or the evens or this row or this pattern here or whatever the case. Or put a little one there, and I'm trying to get these 4 out of the 36. And people will go play roulette and they will study the past spins and go, oh, it hit black 4 times in a row. Don't bet black, red's due. Nothing's due. Nothing's due. But we'll study that. We think and we believe that the world has to even out. Time is infinite. It doesn't have to even out. So the only way we can prove causation is through experimentation. Okay, to take a survey, to observe, to make all these other connections. It just means that this can predict that. It doesn't mean that it causes it. So what an experiment has to do is an experiment has to sort of make everything the same, but just simply change one variable. I'm going to change one variable. I want this group to be exactly like this group, but I'm going to change one variable and see if that one variable makes a difference. Because if changing that single variable makes a difference, then you have something called causation. And again, I think I used this earlier. Let's say I want to say alcohol causes accidents. So that's my hypothesis. That's my research question. So I randomly get a group of participants and get 100 people, and everybody with an odd birthday over here, everybody with an even birthday over here, and the experimental group and my control group. I give my experimental group beer. First I have them drive the course to get the base of are they a good driver or a bad driver, and then I have them drink 4 beers, and then I have them drive again. The control group, I would have them drink 4 cans of what they think is beer. It's got to look like beer, it's got to taste like beer, it's got to smell like beer, because the idea of drinking beer. But that's the one thing I'm going to change. The one thing I'm going to change is the alcohol. So it's not the idea of drinking beer, it's the alcohol that's different. The camaraderie, you drink it fast, none of that. It's the only difference between the two groups is there alcohol in the beer? They're both drinking beer, but is there alcohol in it? That's the only way to prove causation, because you've got to have that control group to look for what is called the placebo effect. Now, the placebo effect is something that's really sort of fascinating. And this is basically the idea of the mind. The mind creates pain. The mind creates depression. The mind creates anxiety. If I throw a snake in the middle of the room and one person looks at it and goes, oh my God, it's a snake, and jumps away, and the other one, oh, it's a snake, let me pick it up. So the snake is the same stimulus, but it's our mind, our amygdala, our reaction. It's going frontal lobe. It's going, oh my God, that's a threat, or that's joy. So if our mind creates anxiety, our mind creates depression, our mind creates, and by the way, I'm not saying overreact, it's just the way our mind is formed. But it creates signals of pain, signals of pleasure, and all these other things, then it's possible for our mind to heal itself. And all medicine prior to about 80 years ago mostly was placebo, and that I'm taking medicine, so I must be feeling better. It's the idea. And there's a bunch of studies on this. The fact that red pills and white pills are more better for pain. A blue pill is better at helping you sleep. Blue pill. But usually when you have a pill that's helping you sleep, it's going to be blue, they tend to be yellow. Big pills, a big capsule is more effective than a tiny pill, even if they have the exact same medicine in them. Because again, it's the idea, it's the ritual of taking the medication. This goes back to when you were a little kid. You fell off your bike, you scraped your knee, you get a boo-boo, and you walk up, Mom, you get a boo-boo. And what she would do is she would kiss your boo-boo and she would make it better. She doesn't have super saliva. She doesn't have healing saliva, but she said it would make you feel better, so it made you feel better. You cause the signals of pain. You can cause a way to block the pain. If you take a look at not anti-prescription, there's no such thing as anti-prescription, antidepressants, Prozac, Paxil, Zoloft, all these, most of their effectiveness is placebo. It's the idea that I'm taking an antidepressant, so this should help me. My wife, who suffers from depression, not because she's married to me, it's been around all her life, but I've kind of been around all her life too, so. But anyways, she sometimes takes her antidepressants, but then sometimes starts to feel better, and she stops taking them, which again, not wise. But what she likes to do is just have the bottle there. Just make sure the prescription's filled and it's there in case of emergency class. That soothes her, the fact that it is there. Faith healers can work. I mean, if you believe in a higher power and that can work. If you go down here, this isn't a link, but if you go to my website, there's a video called Placebo Cracking the Code. And in this video, they talk about what is placebo surgery. And the surgery, now again, you got to have a heart replacement. You need to replace the heart. You can't go, oh, I replaced it. But they had these guys who had arthritis, just arthritis in their knees. So they decided, well, let's scrape out the knee and wash it out and see if that works. Or is it the scraping out, or is it the washing out? But then they decided to take a control group where all they did was they took them in, they put 4 holes in their knee, but they pretended to do surgery on them. And what they realized is that all 3 groups, the washing out the knee, the scraping of the cartilage, and the group that just had 4 holes put in their knee, they all recovered at the same rate. All of them recovered at the exact same rate. So it wasn't the surgery, it was the idea of getting surgery got rid of the pain. That's a placebo effect. Now, and there's other great stories on that document if you take a look. There's also can be the negative effect, which is called nocebo. And this leads to sort of side effects that you have. They did a study of people with that were getting chemotherapy to help their cancer, and what they did discover is that if you gave people fake chemotherapy, which is, chemotherapy is kind of poison, goes in there, just kills stuff. If I give them fake chemotherapy and they think they're getting chemotherapy, it actually helps their cancer at almost an identical rate. But where it's weird, they go, well, let's give them fake because they won't have side effects. They had side effects because they thought they were, they thought they were getting, what was I talking about? They thought they were getting chemotherapy. So since they thought they were getting chemotherapy, they got the side effects of chemotherapy, which included losing their hair, getting nauseous, losing weight. But they weren't getting chemotherapy. But since their body thought they were getting chemotherapy, it went with the side effects that they knew chemotherapy caused. So that's nocebo. This other graphic you see over here, again, these people expected alcohol, received tonic. These people expected alcohol, received alcohol mixed with tonic. Then they wanted to see how aggressive these people were by giving shots to other people. And you'll notice those who expected alcohol but didn't get it were about as aggressive as those who did receive it, because again, alcohol is a depressant and it takes away your inhibitions. These people over here expected tonic water, received alcohol mixed with tonic water. These people expected tonic water and received tonic. So they had no alcohol, they had alcohol, but they weren't expecting it. And notice both of them were a little bit more reserved than these people. So the person who got alcohol had less aggression than the person who expected alcohol but didn't get it. This is all the placebo effect. It's all the placebo effect that goes in right there. Now, when we're doing these types of studies, and by the way, the next lecture we'll talk about experiments, but when we're doing these types of studies, what's very important is the study single blind or is the study double blind? A single blind is there to remove the placebo effect. The single blind means that the participant doesn't know, am I getting the real antidepressant or am I getting a sugar pill? You don't want to tell them, hey, here's a sugar pill. You don't want to do that because then their mind's going to think that particular thing. So a single blind study means the person who is part of the study doesn't necessarily know, are they getting the right medication, are they getting the placebo? They don't know. That's a single blind study. A double blind study is when not only does the participant not know what they're getting or exactly maybe what it's even for, but the person administering the test doesn't know what it's for either. They're just following the operational definitions and trying to replicate it and everything else, but it's not their study. And what's very important about them not doing their study is to not influence the study. If I've got millions of dollars, let's say I got millions of my own dollars, and it's invested in this antidepressant. So it's really important for this antidepressant to work because then I can make billions of dollars. So I'm the one testing my antidepressant. So if I go up to someone, I go, are you feeling better? And they're like, not really. I go, really? Because you look better. You look better? Yeah, you look better. You're not feeling better? Like you say, I'm feeling a little better. Feeling better. That's not good because now my bias is influencing the study. which is why a lot of times when you see these commercials for medication, they'll say in a or in a double-blind study, independent study, and all these other things, we're removing the enthusiasm that somebody may have for their own thing. So double-blind study is the best way to go, especially on drug tests, because you want to remove the bias of the person whose hypothesis it is, because they're human. They want to be true. They want to be right. I think that's it for this particular lecture, if I'm not mistaken. Again, any questions, you can meet me during office hours for Zoom. If you're here face-to-face, come see me after school, email me, whatever the case may be. Your next lecture, we'll be taking a look at experiments. We'll be taking a look at the math involved with that, and we'll take a little bit of a look at ethics, and that will wrap up vocab number 1. And now, as always, stopping recording.